Hey everybody, sorry that I could not be in today, out with my little girl who is sick. So I wanted to still give everyone the opportunity to work a little bit more on target 3 and or work on the study guide that the sub will have for you. I got to different places with my classes yesterday on the target 3 notes. So I'm just going to kind of start over from the beginning here and give some extra examples where we didn't get to those examples in all my classes. So if you need to fast forward to a point where we left off with your class, that is totally fine. So we were solving systems of linear inequalities in the target 3 notes. And as we stated, we need to be able to graph the solutions of an linear inequality before we can graph a system of linear inequalities. So right here is all of the information that we talked about in Unit 3, Target 6, to graph the solutions of a linear inequality. Please take a look at this. If anything here doesn't make sense, go back to our notes in Unit 3 and make sure you brush up on those skills, because of course you can't do 2 of them if you can't graph 1 of them. All right, so really quickly, let's just take a look at an example here quickly together. So if we look, we recognize this is in slope-intercept form. So I know I can pull the slope and I can pull an ordered pair from this equation. Sorry, lost my train of thought there. Pull a slope and an ordered pair from this inequality here. And the slope would be -3/1. And my point would be the y-intercept 0, 5. The inequality is going to tell me whether I include the points on my line as solutions or not, and where to shade the inequality as far as the solutions go. So because this is not equal to, this is going to be a dashed line, and because it is a greater than, my solutions will be above the boundary line. So now I can go to 0, 5. I can go down 3 and right 1, up 3 and left 1. I can graph a dashed line, and I know my solutions are all of the ordered pairs above. Right? We've got to be able to do that to be able to solve our systems. Now, what we're going to do to understand what the solution of a system of linear equalities is combine what we learned about a system of linear equations with what we just went over and reviewed about the solution for a linear inequality. All right, let's change color here. So the solution to a system of linear equations graphically, remember, is the intersection. When we solved by graphing, what we were looking for is the point where the 2 lines representing the solutions of our individual equations in our systems intersected each other. And we are going to combine that with what we understand the solutions to be for a linear inequality. Remember, this is an inequality, so our solutions are no longer the lines, but it is a shaded region. So when we put these 2 together, that we're looking for an intersection of the solutions, which are shaded regions, we get that what we're looking for is the intersection of the shaded regions. We're no longer looking for just a point of intersection, but we are looking for an entire region of intersections. Let's talk about what that's actually going to look like on a graph. Now, on page 2 of your notes here, come on, turn the page there. We have already graphed the boundary lines for you here. So you don't have to graph the boundary lines. We just have to be able to determine where the regions for each individual inequality are, and then where the intersection of those regions is. Now, one way I like to do this is to, instead of completely shading the entire graph twice, let's use little solution arrows is what I call them. So if we look at number 1, you can see number 1 here, and you can see down below our inequality symbol is greater than. So what that is telling me is my solutions are going to be above the boundary line. So I'm going to draw little solution arrows pointing to where these solutions are, which is above the boundary line. All right, and then my second inequality here, you can see this is telling me that I am below the boundary line. So I'm going to draw little solution arrows pointing below the boundary line. Now, these two boundary lines kind of create four regions. We kind of have four regions here. We have region 1, region 2, region 3, and region 4. And if you look, where are the solution arrows both pointing at the same region? All right, well, in the region 1, we only have the red arrows. In region 3, we only have the green arrows. In region 2, we have no arrows, but it is in region 4 that both sets of solution arrows are pointing to that region. That is our intersection of the shaded regions. That is the solution to our system. All right, and I would recommend maybe using this process to keep your graphs a little more neat, a little more tidy. All right, so now we've kind of talked about finding that intersection. Let's put it all together. So let's do an example here. Now, the nice thing about both of these inequalities is they're both in slope-intercept form, which means I can pull a slope and an ordered pair from each inequality here. My slope is -2/1, and my ordered pair is 0.5. This inequality here is telling me to shade above with a solid boundary line. That's a bad S. Let me try that again. Solid boundary line. All right. Now down below here, again, slope-intercept form. So my slope is 3/1. My y-intercept is 0, -2. And this inequality is telling me to shade below with a dashed boundary line. So let's do that one first, since that color is already out for me. 0, -2, up 3 and right 1, down 3 and left 1, and a dashed boundary line. And then my solution arrows are going to go below. So I'm going to draw these solution arrows going down. All right, for my other one here, I'm going to be at 0.5. I'm going to go down 2 and right 1, up 2 and left 1, and I'm going to graph a solid line. Now, if you notice, I'm not overly concerned about where the boundary lines intersect because I'm more concerned about the regions, not the actual lines. I'm going to have my solution arrows go above. All right. So as you look at these two sets of arrows, what region created by the boundary lines are both sets of arrows pointed at? I'll give you a second here to think. And the answer is this region, and that's supposed to be green, but it's not, so we'll just deal with it. All right, so that's where the solutions are. This graph actually shows me the solutions. This shading is the solutions. If you don't have that region shaded, or somehow show me that that's the solutions, you're not going to get full credit. So you've got to make sure that if you do choose to fully shade both inequalities individually, you've got to do something to show me where the actual intersection of those shadings are. All right, let's look at a few more. Don't worry about number 2. We won't give you an equation like this. Notice this inequality is not written in any of our forms. That's not slope-intercept, point slope, horizontal, vertical, or standard form. So we won't give you one like that. So let's skip number 2. And let's go right over to the third page in our notes and look at a few more examples. All right, this one here again is in slope-intercept form. So again, slope -4/3, y-intercept 0.2. Here my slope is -2/1. Y-intercept is 0.6. This inequality tells me to shade above with a solid. This one says above with a dashed. All right, so 0.6, down 2 and right 1, up 2 and left 1, and a dashed boundary line. And I'm going to have my solution arrows going down. This one up here goes at 0.2, and I'm going to go down 4 and right 3, up 4 and left 3. And this one is going to be a solid boundary line. And I am shading also, my bad. I apologize, guys. I shaded these arrows down, and they should have been going up. I apologize for that. So both of my solution arrows are pointing up. All right, and hopefully you can see where the intersection is of my region, and it is right here. All right, be careful when you're shading, you don't accidentally shade an extra region. It's really easy to start coloring and accidentally do this. Don't do this. Don't shade two regions because you can't have two regions that are intersecting. There can only be one intersecting region there. All right, let's look at this one here. Now we have slope-intercept form and we have point-slope form. So this is the same as we've been doing. 0, -3. I'm going to be shading above and a solid line. Here, my slope is now a ninja. Hopefully, you don't forget about your ninja 1 right there. And my ordered pair, remember with point slope form, the coordinates are the opposite of what the terms appear in our actual equation. So this is 1, 2, and this gives me to shade above. Oh, again, I apologize, guys. This first one is not a solid boundary line. It is a dashed boundary line. This is the solid boundary line. So 0, -3, go up 4 and right 1, down 4 and left 1, dashed boundary line. Make it go all the way down here. There we go. And I am going to arrows going up. And then I have -1, 1. So I go to 1, 2. And I'm going to go down 1, right 1, up 1, left 1 with a solid boundary line. And arrows also going up. So where are those arrows both pointing at the same region? It is up top here. All right. Let's look at, well, let's really quickly look because these both have two different ones here. Again, slope-intercept form. M is -1/1, 0, 4. This is telling me to shade below with a dashed line. All right, now this is horizontal form. Remember, this is a horizontal line. So my slope is 0, and I can pick any point I want with a y-coordinate of 8. I'll go with a y-intercept there. So this is telling me above and solid. So 0, 4, down 1, right 1, dashed line, and my solution arrows going down. All right, and then I have 0, 8 way up here. I have a solid boundary line with my arrows going up. All right, now this one can be a little tricky to see because it's all the way up here in a corner, but the arrows are pointing at, both arrows are pointing at this very top corner here, which looks small, but we know if the coordinate plane kept going, that would actually not be that small. It would be, infinitely large. All right, our last one to look at here. I'll change colors so you get a little bit different here. This is vertical form. So remember, this is Vux, and our slope is undefined, and I just need any, oops, that looks like a 9. Let's change that. I need any ordered pair that has -4 as the x-coordinate. This again is telling me to shade above with a solid line. This is also telling me to shade above with a solid line. This is in slope-intercept form. So 2/1, 0, -6. So let's graph my vertical line. I go to 0, -4. I graph a solid line. Now, when we think of shading above with the vertical line, that means we're actually going, our solutions are going to the right. So then I'm going to graph this 0, -6 up to right 1, down to left 1, dashed or solid. This one's also solid. Now this is interesting. Look, these lines don't actually intersect on our coordinate plane, and that is okay. We don't need them to intersect in the coordinate plane because we don't care about where the boundary lines intersect. We care what region are both sets of arrows pointing at. And what we really kind of see right now are three regions. We have a region to the left, a region in the middle, and a region to the right. Now, if we were to extend our graph down further, we would see these lines intersect each other. Whoops.